Okay, we have the question here. The polynomial h of x equals p open brackets x minus 1 squared plus x open brackets x plus 2 squared. So this polynomial is divided by x plus 1 and x minus 2. And when you divide these polynomials, you get a remainder of 3. Okay, so when you divide this polynomial here, colleagues, what is a polynomial? Before we even go further, what is a polynomial? Mr. Kasono, what is a polynomial? Okay. Polynomial, it's just the number of terms in a equation. Okay. When there's one term, it's a monomial. When it's two, binomial. Three or more, that's when you start with the polynomials. Okay. It's just about the number of terms in the equation. So basically, this, if you expand it, there are going to be more than three terms. Okay. So that's what a polynomial is basically. It's just the number of terms in an equation. Okay. So when this polynomial is divided by x plus 1, the remainder you get is 3. Then when this same polynomial is divided by x minus 2, the remainder is negative 15. So this question is saying find the values of P and Q. Okay, so as always, let me just put the question here. We'll put it in a step-by-step process here. Okay, these are the steps. Okay, step 1, find the zero of the linear equation, not polynomial, linear equation by setting it to 0. Okay, I'll go through these steps later on first. Okay, let me just put the equation here. H of x equals p x minus 1 squared plus q x plus 2 squared. And when it's divided by x plus 1, our remainder is 3. And when it's divided by x minus 1 or x minus 2, our remainder is negative 15. Okay, so these are the basic steps that you have to do. This topic is on the remainder theorem, still in algebra, okay, where on division of polynomials, when you divide polynomials, sometimes you're going to get remainders, okay. So the first step with this equation, with this type of questions, is find the zero of the linear equation by setting it to 0. So our linear equations are this one here, this one, and this one. So when we say the zero of a linear equation, it means it makes that linear equation 0. Okay. So what we're basically saying is this first linear equation, x plus 1, equate it to 0. Take the 1 to the other side. X equals negative 1. This negative 1, when you put it in this equation, it makes this equation 0. Okay. For equation 2, you get also the 0 of the equation. X minus 2 equals 0. Just take the 2 to the other side, x equals positive 2. Okay, this is the first step. Get the zeros over each linear equation. You'll be given the linear equations in the question. Get the zeros of each of them. Any questions before we move further? Remember, these two are divided by the polynomial. When you divide these two by the polynomial, it's stated in the equation here, is in this x plus 1 and this x minus 2. These are the ones which we have equated to 0 to get their yes. Okay, so first thing, when you see this question, you start with this x plus 1, x minus 2, whatever you'll be given. Okay, equate them to 0 so that you get the zeros of the linear equation. Any questions before we move to step 2? Uh-huh. Yeah, I think we can say that. I think it can be fair to say that. I think it can be fair to say that. Find the value of x for the linear equations. Can be fair to say that, madam. Thank you for that observation. I never so took it that way. But please, it's not these ones in here. Do not make a mistake that these ones you do this. No. In the question they'll provide for you, okay? So please do not take these ones here. Can we go to step 2? Step 2, substitute these values. This x equals negative 1 and x equals 2. Substitute them into both into this original polynomial. Okay? Substitute both of them into the original polynomial, each at their own time. Okay? And then equate the polynomial to the remainder. So basically, this is what we're saying. Our polynomial here, h of x, replace x with negative 1 equals p, open brackets. So where there's x, we're starting with this x equals negative 1. Okay, so where there's x, replace it with negative 1. So p, open brackets, negative 1 minus 1, use orange so that minus 1 squared plus q, open brackets, substitute x with negative 1 plus 2 squared. Okay. Then equate this to the remainder. Remember, the remainder for x plus 1 is, the remainder is 3, so equate this to 3. Okay. And then you simplify now. Negative 1 minus negative 1, negative 2. Negative 2 squared, that is 4. So you're going to get 4p plus negative 1 plus 2, that is 1. 1 squared times q, you're going to get q. So you say 4p plus q equals 3. and you label this as equation 1. Any questions? Mhm. Yes, it's just telling us that where there's x, we're replacing it with -1. So its row ends just there. No need to bring it down here and everything. No. Just saying where there's, yes, where there's x, we're substituting with -1. Colleagues, is this more consumer friendly than binomial distribution? Is this more consumer friendly? Mhm. As I said, this, what it's telling us here is that in the polynomial here, where there's x, substitute it with -1. Oh, no, no, no. Yes. Uh-huh. Colleagues, why are we concentrating on this age? The age, that age just go after you put that, the age, forget about it, okay? It's gone. Forget about it, it's gone, okay? It's just as I said, it's just representing that. It's just saying that where there's where there is x, we're substituting with the -1, okay? If I wanted, I would have even removed it. I wouldn't have even put it there. I would have just put state like this. Okay. So don't worry about this age. Okay. Once you put it there, leave it there. Don't show it again. Okay. No. Or dy dx. Sir, now how are we bringing calculus here? Sure. This is how. You confuse people. Here there's no dy dx. Mm, you want people to start leaving the meeting. Hey, you want people to start leaving. Okay, so we are done with this first one here. Let's now go to this one. This for this x minus 2, where we said x equals 2. We substitute x equals 2 into um, the expression above. Okay, so I'm going to say when h open brackets +2 equals, we're going to say p open brackets, where there's x here, substitute it with 2 minus 1 squared plus q open brackets. So here, where there's this x here, substitute it with 2 plus 2 squared. Okay, then always equate the remainder at the end equals -15. Put it proper, equals -15. Then we simplify so that we get our Okay, because here basically the concept is once we form these two equations, we just use simultaneous equations to get the values of P and Q. Okay, so when we simplify, 2 minus 1, that is 1. 1 squared, that is P, plus 2 plus 2, that is 4. 4 squared, that is 16. So we have P plus 16Q equals negative 15. Okay, so this is our equation 2. Okay. So remember, first step, the linear equations that are given, equate them to 0 and get the values of x. Then those new values of x that you've got, substitute each of them into the original polynomial equation so that you can set up the simultaneous equations. Any questions? So this is equation 2. It's the remainder. It's the remainder. These remainder. Huh? Negative 15. Yes, yes. If you remember here, yeah, remember this part here. Mhm. Okay, okay. Any questions, colleagues, before we solve the simultaneous equations? Let me write them down here. Mhm. Mhm. Come again? For P. Uh-huh. No, no, sir, no. 3Q. These three is just this remainder we're given here. And there's no Q to multiply it with. Okay, so we now solve the simultaneous equations to get our values. So colleagues, which one should we use? Elimination method, substitution method, Cramer's rule? Which one? Okay, we can use substitution method, okay, because we can easily get we can easily make P or Q the subject of the formula, okay? If you notice that you can easily make one letter the subject of the formula, the best advice is use substitution method, okay? If that's not the case, you can still use substitution, but elimination, you can use it also too. So here we can say, okay, let's make Q the subject of the formula here in equation 1. We make Q the subject of the formula. Okay, meaning we take this 4p over the other side, so our new equation becomes Q equals 3 minus 4p. Okay, we've adjusted equation 1 and made Q the subject of the formula. Any questions before I move further? Okay, so this new equation, put it into equation 2. Okay, p plus 16. So substitute Q with 3 minus 4b equals negative 50. Okay, remember this is equation 2. Oh, let me not put it like this. You might think I'm subtracting from 2. But yeah, remember this is, so we've just put this new equation we got for Q into equation 2. So we solve. 16 times 3, 48. 16 times negative 4, p, what do we get? P equals negative 15. So we put like terms together. So this positive 48, the positive 48 will cross over the equal sign. Okay, so we have p minus 64p equals negative 15 minus 48. P minus 64p, we get negative 63p. Negative 15 minus negative 48, what do we get? So to get our value of p, just divide both sides by negative 63. So p equals positive 1. Any questions? Yes, this one here. Yeah, was let's see, if you factorize, I'll try it in my spare time. I'll see what can happen. But please do not factorize colleagues here. Okay, please don't. Just yeah. So this p equals 1. You can substitute it into here. Okay, to get our value of q. So q equals 3 minus 4. So we substitute p with 1 So 1 times negative 4, that is negative 4. 3 minus 4, negative 1. So P equals 1, Q equals negative 1. Questions, queries.